animals are on the move and faced with the risk of predation, they often display an adaptive spatial patterning to minimize the danger. But with the continual encroachment of mankind into natural habitats, it's not only ecological dangers that pose a threat, the man-made challenges now provide a new and emerging danger. How animals respond to these man-made dangers is surprisingly unclear. In order to determine the response to man-made threats, a group of meerkats living in the Kalahari Desert was used for the study. Meerkats are a cooperatively breeding social mongoose that are often exposed to both terrestrial and aerial predators. Recently, man-made threats have started playing a larger role in their daily lives, as their home range has been divided by a busy road, which accounts for many mortalities. The researchers hypothesized that despite the relatively new appearance of the road, the meerkats would be able to use their naturally evolved socio-spatial patterning to minimize the dangers presented. Road crossing observations were carried out on 4 groups of wild but habituated meerkats at the Kalahari Meerkat Project within the Perony River Reserve. The animals were tagged as subcutaneous transponders and died for individual identification. The observations were carried out on a main road running parallel to the reserve. Road crossing events were classified as when a group of meerkats stopped foraging, approached the road together, and crossed in one fluid motion. During these events, it was recorded which individuals led the group towards and across the road, and if these individuals were dominant or not. A total of 52 road crossing events were recorded, and a self-propelled particle model was used to analyze the data. It was discovered that meerkats do have the capacity for flexible problem solving through the application of phylogenetically-old behavioural strategies. The observations suggest that the dominant females led the group towards the road, but once it was reached, a reshuffling in the social order began, and the subordinates were more likely to cross first. The dominant females seemed to minimize their own risk by actively avoiding the exposed positions, reducing their own likelihood of injury or death on the road. This avoidance strategy demonstrates a selfish herding behavior as the dominant individuals reduce their own domain of danger at the expense of the subordinates. This computer simulation demonstrates how a group of 8 meerkats negotiated the road. The behavior of the dominant individuals, colored in red, differs between approach and crossing. With the size of the human population continuing to grow, human and animal collisions are increasing. Research such as this shows us that animals are capable of using phylogenetically-old behaviors to react to modern-day threats. Results such as this give us a glimmer of hope, demonstrating that animals, in some instances, can adapt to coexist successfully with mankind.